my dear students, today we will discuss circle of class 10. First see this figure. Here it is a circle and it is a line. This line does not intersect anywhere to the circle. So it is called a non-intersecting line. This line intersects at 2 points. So it is called a secant. This line intersects the circle at only 1 point. So this is called a tangent to the circle. See here, in the first case, A is an interior point of the circle, so we cannot draw any tangent to the circle through A. Here, B is a point on the circle, we can draw only one tangent to the circle, and here C is an exterior point of the circle, so we can draw two tangents to the circle. Theorem 10.1 is the tangent at any point of a circle is perpendicular to the radius through the point of contact. Here see this, xy is a tangent, P is point of contact and OP is radius through P, that is OP is radius through the point of contact. We need to prove that the tangent at any point of a circle is perpendicular to this line is perpendicular to the radius through the point of contact, means OP is perpendicular to xy. We need to prove this. OP is perpendicular to xy. We need to prove this. For this purpose, let's take a point Q on xy such that Q on xy, and we have to join OQ. Let's write this. Let Q be a point on xy and join OQ. For any point other than P on xy, Q will be the exterior point. Let's write this. For any point P, for any point Q other than P on xy, Q will be an exterior point of the circle. From the definition of exterior point, we must write OQ is greater than OP. So OQ is greater than OP. Let's see another concept, that is, if this is a line, let it be MN, and here is a point, suppose this point is C. The line joining the point C to the points on MN. Let's join some lines. Draw one is shortest line. These are the several lines that join C to the points on MN. The perpendicular distance will be the shortest distance, or the shortest distance is perpendicular to MN. We know it very clearly. So OQ is greater than OP. For any point on xy, OQ must be greater than OP, or OP is the smallest point, or OP is the smallest line. Among all lines joining from O to the points on xy, so we can write OP is the smallest line, hence OP is perpendicular to xy. Now theorem 10.1 is proved. Theorem 10.2 is the lengths of tangents drawn from an external point to a circle are equal. So PQ and PR are the tangents to a circle with center O. Let's write this. Given that PQ and PR are the tangents from tangents from an external point P to a circle with center O. We need to prove that to a circle are equal, both the tangents are equal, we have to prove that. So we need to prove that PQ equal to PR. For this purpose we need some construction. Construction is join OQ, OR and OP. Join OQ, OR and OP. Let's join this OP, OQ and OR. We have construction, so it can be dotted lines like this. Now let's prove this. So now compare triangle OPQ and ORP. In triangle OPQ and triangle OPR, what are equal between these two triangles? We have already proved in theorem 10.1 that the radius through the point of contact is perpendicular to the tangent. So we can write angle OQP is equal to angle ORP, each 90 degree. Again OP is common side, so we can write OP is equal to OP, this is common side, and OQ and OR are equal. OQ equal to OR. This is the radius of same circle. So we can write here radii of same circle. So by right angle, hypotenuse and side criteria for the congruence of triangle, we can write triangle OPQ is congruent to triangle OPR by right angle, hypotenuse and side criterion of congruence rule. If two triangles are congruent, then their corresponding sides and corresponding angles must be equal. So in this case we have to write only PQ is equal to PR. PQ equal to PR by corresponding part of congruent triangles. Now theorem 10.2 is also proved. This is the all concept from the chapter circle. Thanks for watching. Thank you my dear students.